Thank you, Tara. All right, hopefully you can hear me. Yeah, so as Tara mentioned, my name is Chen Wang from AI21 Labs. Really glad that we're in this spot. And you're all caffeinated and we're warming up for lunch. So hopefully you're comfy and enjoying the time here in Boston. So yeah, today's talk, we'll be talking more about agentic AI applications and the framework we're developing. So a little bit more background about the company, AI21 Labs. So the company started as an NLP research lab, and we currently focusing on really enterprise AI solutions, including large language models. So you might have heard a really unique model called Jamba has a hybrid architecture of transformer and Mamba, which make it very efficient. And we're rolling out a AI agent offering, AI21 Maestro, and will be today's topic. Sweet. Yeah, so as we all have been living in this world where AI is rapidly developing and there's new innovations and new tools coming out every day, right? So it's worth to step back and ask ourselves a basic question, right? So what do we really want from AI? On the high level, basically, we as users, we want to set a goal, and then we want AI to actually deliver the results and really, so we don't have to spend all the effort of getting through all the information to get the answers you're looking for, right? So the most precious resource these days are basically our attention, right? So if AI can do all the job for us, so we can just spend our time on social media and Netflix, which would be good. But there's one small problem. Does anyone recognize what this picture is? Exactly. Thank you for this gentleman in the middle shouting out the answer. So if you're a classic sci-fi fan, you probably recognize this is something called HAL 9000 from the classic sci-fi book and movie 2001: A Space Odyssey. And the gist here is that HAL is a AI system that operates spacecraft on a mission to Jupiter. And it is being assigned for a singular goal of ensuring the successful of the mission. And halfway through the mission, HAL decided that all the human crew on board will jeopardize the mission. So it starts to kill all the humans. So that's clearly an AI dystopia scenario where AI are given a goal, but what's lacking is the constraint of achieving those goals. So being giving the goal to AI is not enough, right? AI needs constraints. And if you're, again, classic sci-fi fan, you can find probably a solution in this AI dystopia problem from another source inside the same sort of realm of sci-fi material. Isaac Asimov's 3 laws of robotics will actually be a perfect constraint for this scenario. So what do we really, really want from AI, right? If we consider all these unwanted scenarios that involve AI. So this fun kind of sci-fi story aside, especially in today's enterprise environment, right? We do want human users to set up a complex goal so that AI can help deliver accurate results and also provide explainability, being transparent about it. But also, we want the results to really fit in the set of constraints that human sets. So especially in regulated industry or in use cases with high stakes, you don't want AI to go wild and produce something that is not wanted really by the user. So AI without constraints is best useless and often harmful. Let's imagine this scenario. Imagine you're a knowledge worker inside a enterprise, and this type of question is very common. Let's say for an analyst to deal with on a daily basis in investment bank, hedge fund, or credit rating agency, for example. you want to gather all the information, analyze the financial performance of some public company, in this example, Microsoft. You're looking into getting information of trend between 2022 to 2024 for a few different business segments. And you also want the results to be displayed in a table, and the value of the revenues in billions of dollars in the right units consistently. And you also want a reason and everything in bullet points. So with all the constraints, with all the questions, we're looking for the AI system to give you an answer, right, that fits in all the constraints. So this is not a trivial question, right? So for anyone who has gone through a similar process, to generate an answer for this type of question by yourself, looking into different documents like 10K, 10Q, the SEC filings, and whatever internal data sets you have access to, it can take you hours and hours to get something like this to compiled. But today, with today's Gen AI tech stack, you can really get the answer for this type of question, with a single call to agentic AI systems. So maybe let's look into a little bit of what does agentic AI system today, with today's tech stack, really consist of. So with agentic AI system, of course, we want to solve things that a single call to the large language model is not able to resolve. So that typically involves some really complex queries, as we mentioned earlier. So the first step of this whole process typically involves some sort of goal decomposition, right? So decompose a complex goal into smaller subtasks, and then constructing an execution plan to solve these subtasks one by one, right? And if your organization cares about cost and latency, then there's typically some sort of time and cost budget limitation into it. In the execution side, so LLM, large language models, are still the core of solving a lot of complex questions, leveraging its reasoning and its sort of building knowledge from pre-training and fine-tuning. And with RAG and other capabilities, having the language model have access to the relevant database, internal documents, internet searches, different web APIs, and customized functions, and also running code, executing code, is also often an essential piece of the entire system. As LLM still is the probabilistic nature of LLM, having human in the loop to providing assistance and guidance is often very critical to ensure the outcome. And as we mentioned earlier, with the constraints, we as user wants to make sure the output meets. Having the system to validate the answer and improve if needed is also critical, on top of the human assistant, just because when you get to a use case in scale, it's often impossible for human to inspect every single answer coming out of LLM. And finally, when the output is generated, ideally you also want some sort of report to really document each single execution step with the validation and the regeneration steps documented, all different parameters used in this whole process as well for auditing purposes, whether internal or external. And with sort of this AI agentic AI system, today there are mainly, if you really, there's many different ways to slice and dice this. But if you really look at the core, there are two major patterns that really made up most of the agentic AI systems today. Right? So as of now, people are typically referring them as agent and workflow. So agent is basically a really compact system where a pattern where LLM is at the core, and the user assign a system message to the LLM that typically assign a role and a scope of work to the LLM. And an LLM has access to a set of tools, typically RAG, internet search, and code interpreter, so on and so forth. And the LLM, based on the user input, the prompt, the agent or the LLM will iteratively trying to resolve the question, the query, with the help from the tools and giving you the response. And with workflow, basically you can define a static logic to execute a workflow plan with multiple agents involved, and this is just a illustration, but it doesn't have to be linear. It can be more complex, have various logic involved, including the classification and validation, and so on and so forth. But there are challenges with each of these core patterns. With the agent pattern, really because we're relying on LLM to handle the decision making and to know when to call which tools, and LLM can make mistakes, and due to its stochastic nature. So we can refer to this as a approach called prompt and pray. So you're sending your prompt and crossing your fingers and hoping the LLM will give you something you want. And especially as you go through an iterative process, the error rate can compound and quickly make the system unreliable. And also, you got to predefine the system message, the LLMs you use, the model you choose, and the set of tools you want to use. So it usually sort of involves a lot of predefining of the agentic system, and actually makes a lot of work labor intensive, and kind of defeats the purpose of actually using agentic systems to help you automate the process. With workflow, the challenges are it's static. Again, you got to predefine the logic, and makes it usually fits to a very narrow set of user queries. And so that renders, again, if you have a pretty wide range of user queries coming in, you sort of have to fine-tune and redefine different workflows for different set of user queries, and really delays and slows down the dev cycle. And if we think about what different personas want in this whole process, so AI builder looking for something that is efficient to build and iterate, and easy to troubleshoot. And AI consumers are looking for something that's accurate and also explainable, right? And today's agentic framework are kind of lacking on both fronts. That's why at AI21, we are developing taking a new approach, developing this agentic framework called AI21 Maestro, really to kind of tackle the problem from both ends. On the one side, to really autonomously being able to plan and execute, sort of function as an agent factory. So the system will automatically decompose the goal into subtasks and construct a workflow plan, and also automatically parameterize each agent, so you don't have to do that by yourself manually before you actually see the results. And it also delegates the right task to the right agent. And also, we enable something called generation with constraints. So instead of sort of writing a massive prompt with your query, and also keep adding in all the constraints in the same prompt and hope the results will come out right, we enable user to define individual constraints, like a bullet point, and the system will automatically validate the constraints individually to make sure the results are met with all the constraints defined by the user. Yeah, so this is a little fun picture. And clearly you can see that I drew this picture by my hand on a piece of paper. So we'd love to use the same question, because we already talked about it, to kind of illustrate how AI21 Maestro work. Right? So again, same questions. If a financial analyst is looking for answer to this question, looking for growth rate for Microsoft, 3 business segments from those 3 fiscal years, and also explaining the key factors or driving the growth for these 3 factors, and also including the constraints, how you want the results to look like, things in a table, again, kind of in the right unit, calculating certain columns or attributes you're looking for, and also listing all the factors in bullet points, right? Very normal for something in enterprise knowledge worker kind of setting. Hopefully you can see this, but basically with AI21 Maestro, you don't have to define this work plan, and the system understands that, hey, in order to solve this question, first I need to run these individual queries to get information for each of the business segments, the revenue at each of those 3 fiscal years, right, on the left-hand side. And with those raw information, I got to create a table, I got to calculate the growth rate, and find out which sector is growing the fastest, and then come up with a coherent list of factors, and then finally aggregate all these answers into a coherent final response, right? So the workflow plan is being constructed by the Agentic framework rather than by yourself, manually before you knew what's going to come out. Right? So, and internally, behind the scene, the system are generating the entire workflow plan into this we call PDL, planning definition language, basically the subset of Python that you can actually see and alter if needed. So the plan is very much visible and transparent to the end user. So that's sort of the macro plan, right? And then if you look in the micro level at each execution step, for example, if you're looking for one of the business segments at one of the fiscal years to retrieve the information from for example, SEC documents, a 10K or 10Q, or 10K in this case because it's annual. There are also different retrieval strategies, right? In this, for example, a RAG system, there are different retrieval strategies, different retrieval parameters, and then you can choose different models, and each model can have different parameters as well. So there's a lot of things you can actually try and test, and each route will give you different cost, time, and success rate. So as a AI application developer, you don't want to just test all of these options because it's going to be very time consuming. So AI21 Maestro as a system will actually have a prior to, based on the type of question, the complexity of it, it will pick the most promising routes for you automatically, and also test them iteratively, and validate, and eventually pick the route that meets all the constraints and give you the final answer. So really, again, automation is a key here to help you become more efficient when you're developing this set of applications. You don't have to manually testing out different combination of parameters, while in the same time the answers are validated to make sure the results are satisfactory. So after this whole process, the final answer will be generated for you in the sort of meeting all the constraints that you defined. And by the end, a execution report will be generated, and also tells you, hey, which requirement has been met, so on and so forth. Here's a little short video, demo video, to give you a more clear idea. So here you gave the instruction and requirements to the system. And in here, want you to pay attention to the budget setting here. Again, this is something we might change. But for example, when you start, you can set the budget to low so that the system will give you a quick answer, and you can inspect how good it is working. And you can add each individual requirement a single bullet instead of compounding a large prompt. And you can see the execution step. And in this case, with low budget setting, not all the requirements have been met. So you can come back and increase the budget for the run and regenerate again. And now you can see actually in a second that the execution steps has expanded and become a lot more, and kind of leveraging more compute resources to help you give an answer that meets all the requirements. So let me try to move from here to the next slide. Yeah, so again, kind of how the AI 21 Maestro is really designed to automate and help the whole process to be more efficient when you're developing AI applications, and also in the same time make it reliable. So the scenario to consider using a framework like this would really around in enterprise use cases really require high reliability of the whole system you're developing, and especially when your question involves complex queries that needs information from multiple sources, and then compare and aggregate and some sort of multi-hopping reasoning that you need to chain the logic together to give you a final answer. So these are a type of question that a single LLM won't be able to handle at the moment, and agentic framework like AI 21 Maestro could be really helpful in this type of scenario. And for all agentic AI systems, agentic frameworks, right? So the end goal really, one of the major goals is to improve the reliability of the AI systems from a LLM. And that's no different for AI 21 Maestro. And again, this is a model-agnostic framework. So we have seen that really the AI application's ability to follow requirements and also be able to resolve complex reasoning tasks with constraints have boosted significantly with AI Maestro involved. So by the way, on the right-hand side, a frames benchmark is a benchmark developed by Google that evaluates how well a model or a system performs over complex reasoning with multiple constraints. And you can actually go check it out, see some of the typical examples. Those actually really good examples of showing what type of queries are really fit for today's agentic AI frameworks. To round it up, here are a few key differentiators for AI 21 Maestro. Automated planning. Right, so no need to manually craft the plan before sort of you know what's going to come out from the other side. And also the tasks are routed to the proper model, as we talked about earlier. So you don't have to test all the different combinations. There's many models, there are many retrieval strategies, many different parameters you can choose. So all those are automated. With a planner model and with action model to help you optimize those choices. Again, you can apply budget to limit cost and latency, depends on the specific requirements in your use case and in your organization. And the results are also verified at individual requirement level, right? Instead of having all the constraints written in the same prompt as your query and hoping the results come out right, the system will actually help you to verify individual constraints and regenerate the answer, improve it if needed. So AI 21 Maestro is coming out in the private beta will be out in the next 1 or 2 weeks. So if you would like to get your hands on it and play around, as early user, feel free to scan the QR code and join the queue. And the public beta is scheduled to be out at end of June. So hopefully, you'll all enjoy and have fun with it. Awesome. So that's those are some cool things I would love to share today. And I think we have a few minutes for any questions.
Hi. So very cool. About the validation, what happens if it fails? Like, if I think of like, try catch exception, how do I handle it? Or is it up to me as the developer using the framework to build a human in the loop? Or, and what I'm thinking about is like, do you go back and rewrite some of the system prompts so that you can get better validation?
Yeah, no, that's a great question. And also internally, when we test, sometimes we would on purposely trying to be the system where we have potentially contradicting requirement constraints right in there and see how the system behaves. So yeah, so that's a great question. So of course, this is again a stochastic system, so it won't 100% cover all the edge cases. So the goal here is definitely to improve over time. But as you mentioned, there will definitely be edge cases where it will escape the system. But the way the logic it works is that it will explore all the different combination of retrieval and in a RAG context, different retrieval and kind of model parameters to see which route gives you the best answer. So instead of you kind of trying out individual routes, it gives you a better chance of giving you what you want.
So subject to the budget constraints that I put, or the budget parameters, let's say, not to overload constraints, it's doing retries and rewrites under the hood so I don't have to, and then it's reporting to me, this is my optimal results.
Exactly.
Cool.
It explores multiple passes, and at each pass, it will reiterate if needed to give you what you need until it meets either the budget exhausted or it meets all the constraints.
Hi, thank you for the talk. I was wondering if the model has the ability, or the agent has the ability to learn from its own behavior. So maybe like at the start of every new quarter, on the third day, we run the same kind of analyses.
Yeah.
Would it be automatically be able to know, okay, so for the second quarter, on the third day, they ran this type of analyses. At the end of the third quarter, they might want to do the same thing.
Yeah, no, that's a great question. So this is something we're actually actively developing. It probably won't be in the first public release version. But something we're working is today, again, there's the planner model. There's this action model where it predicts which model and which route will be the best fit to execute your question specifically. Over time, we're developing to make that, so an action model basically had a prior to predict which route is the best for your question. And it's something we're working on to actually have ability to update the prior based on user queries. So that's something we're working on. So hopefully that will be out at some point, second half this year, so that based on kind of organizational or personal usage, the action model will learn to adapt and predict a sort of more fitting choice for individual queries over time. Awesome. Great. So hopefully, you will continue enjoying the conference, and we'd love to catch up after the session if we happen to talk to each other. All right. Have a nice one.